Let's draw a plausible mechanism for both minor and major product. First, recognize that the acetate ion is a nucleophile, and we have a substrate that bears the leaving group. The minor product is easy to form because the minus charge on the nucleophile is going to attack our alpha carbon, and in turn that's going to create a leaving group, and there we have it. Okay, so we have a minor product here. Now the major product is slightly more complicated, and you have to identify the three-membered ring now becomes four-membered ring. So there must be intramolecular nucleophilic attack that's tethered in this structure. I notice that methyl is still preserved, so that means I have to form a bond between the nitrogen and the alpha carbon. The nitrogen here has a lone pair that's going to act as a nucleophilic center. So kind of ignore the methyl group, more focus on the way how this the lone pair is going to attack our carbon over there. So we have like a one side, two side, and then the third side between the nitrogen and carbon. So it's going to be a triangle, and then the bromine is going to be a leaving group. Thing is, we get the two three-membered ring that involves the nitrogen. And then for simplicity, I'm gonna draw a simple geometry like that. So this methyl is referring to that, and that orange arrow, the bond, is between this nitrogen and that carbon over there. Okay. Oh, and don't forget the R group. The R was defined in the problem as CH2 and argon there. But notice that nitrogen has to bear plus charge. Reason? Well, he has a 1, 2, 3, 4 bond, no lone pair. Nitrogen has a group number of 5, so 5 minus 4, you get plus 1. Thing is though, we have a very strained triangle or three-membered ring, and we have two of them. To release that strain, to relieve them, the bond electron that forms the bond between the nitrogen and the corner carbon can actually place on the nitrogen to mitigate the plus charge, and in turn that's going to create a tertiary, although that's preferred carbocation rather than the primary. We have a tertiary carbocation, and it looks like this. Okay, and where is our nucleophile? That's acetate ion. So he's gonna come and attack that tertiary carbocation, and that's how it makes the major product.